how can we take a number that is in scientific notation and convert it into standard notation or standard form? So remember the rules from the last video, which were if we've got a positive exponent, that means that our number is going to be large, larger than 10. And if we've got a negative exponent, our number is going to be small, smaller than 1. And so that's going to be an important piece of information here in just a little bit. Let's start with our first number here, 6.32 times 10 to the ninth power. So 9 is a number that is larger than 1, and that tells us that our standard form answer here is going to be large. It's going to be a big number. And to make a number bigger, we take the decimal point where it is right now at 6.32, and we're going to move that decimal point to the right. And we move it to the right because moving a decimal point to the right makes a number larger. For example, right now our number is 6.32. If I moved this decimal point one spot to the right, it would become 63.2, which is larger than 6.32. So moving the decimal point to the right makes the number larger. So let's write that down. Moving the decimal point right makes the number larger. I bet you'll never guess what moving it to the left does. So this is going to be a larger number when we write it in standard form. Moving it once turns it from 6.32 into 63.2. To turn this into the correct number, how many times do we need to move it? Well, of course, the exponent is telling us that. We need to move it 9 times. So here's the problem. After I move it one more time, so I've moved the decimal now a total of 2 times, my number is 632. I started off with 6.32. I move it one time, I'm at 63.2. I move it a second time, I'm at 632. So I've moved it 2 times, I have 632. I still have to move the decimal 7 more times, but I don't have any more numbers in this problem. What should I do? Of course, I'm going to start adding numbers, and what numbers do I add? I'm going to add zeros. So since I need to move the decimals 7 more times to get up to the total of 9, I'm going to add 7 zeros. So let's count them. 1, 2, 3, 4, 5, 6, 7. And then we'll go back and put in our commas so that the number's easier to read. And this means 6.32 times 10 to the ninth power is 6,320,000,000. That's it. So let's try it with a small number, 4 times 10 to the negative seventh. So moving the decimal to the left is going to make this number smaller. So right now it's 4. If I move it to the left one time, the number becomes 0.4. Okay, so 0.4 is what happens if I move it to the left one time. But now I have run out of numbers. I can't move it to the left anymore. What do I do? And just like with the big number, I add zeros. So I've moved it one time to make 0.4. I need to move it 7 times. So I need to move the decimal 6 more times. So I'm going to add 6 zeros. So let's do that. Let's count the zeros here. 1, 2, 3, 4, 5, 6, and then we'll put the decimal point right there. And of course, it's good math practice to never start a number with a decimal. We usually want to put a leading 0 there. And so 4 times 10 to the negative seventh is, I'm going to have to count my place values here, tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, 10 millionths. So this is 4 10 millionths is 4 times 10 to the negative seventh power. And that's how we can take a very large number, like 6.32 times 10 to the ninth, or a very small number, like 4 times 10 to the negative seventh, and write them in standard form, which we would do if we wanted to know exactly what the number was. So if I had it in scientific notation and I wanted to know like exactly what is that number, this is how I would figure it out.